Algebra 2 5.8a, words translated into factorable equations. Now it's really important, if you haven't seen the previous videos for Chapter 5, there's links in this video's description. You need to watch from 5.4a through 5.7 to understand factoring polynomials and the principle of zero products for this video. So sometimes a problem will ask for a number, x, and the solution will give us more than one number. It might give us x and another value for x. Take a look at this one. The length of a side times the length plus 3 is 180. We can break this down into the length of a side as s. Times means we're going to multiply. The length, that's another s, plus 3 is 180. What we can do is write it so that the s plus 3 are in parentheses equals 180. We can add a negative 180 to each side of the equation to set it to equal 0 using that principle of zero products we learned in the last video. We set it to equal 0 before we factor it and solve it. We can distribute this s to each term inside the parentheses and get s squared plus 3s minus 180 equals 0. Now it's ready to be factored. So let's take a look at this one. The square of a number minus twice the number is 48. And the square of a number is x squared or n squared or whatever variable we choose. Minus means we're going to subtract. Twice that number means 2 times that variable, in this case 2x, and equals 48. Now we've got our equation. And using the principle of zero products, we can add a negative 48 to each side of the equation and set it to equal 0. Now it's ready to be factored. The x squared can be broken into an x times an x, and this negative 48 needs a negative factor in order to be a negative. So it's either a negative 8 and a positive 6, or a positive 8 and a negative 6. Well, in this case, the negative 8 and the positive 6 work. We can try each way. And using additive inverses, we add a positive 8 to each side of this. See, we set each one of these to equal 0. See, it's this or this. And this creates a 0 pair here, and we get x equals 8. On this side, we add a negative 6 to each side because that's a positive 6, and we get x equals a negative 6. Now we take this 8 and this negative 6 and we plug it into the original equation. We substitute it in. In here, we use the 8 and see if it works, and yes, it comes out that 48 equals 48. We try it again using the negative 6, and we see that 48 equals 48, so yes, x equals 8 or x equals a negative 6. They both work. Okay, let's try another one. We've got 4 times the square of a number is 21 more than 8 times the number. Well, 4 times the square of a number means 4 times x squared, or 4 times n squared, whatever variable you choose. Is usually means equals. 21 more is 21 plus, and 8 times the number is 8 times that variable, 8x. Now we have our equation, 4x squared equals 21 plus 8x. Now, we need to set it to equal 0, but I don't want a negative 4x squared. Here's the equal sign. I could add a negative 4x squared to each side of the equation to set it to equal 0, but I don't want a negative 4x squared. So what I'm going to do is I'm going to use this side of the equation. This is a positive 21. I'm going to add a negative 21 to each side. This is a positive 8x. I'm going to add a negative 8x to each side. And that gives us a positive 4x squared minus 21 minus 8x equals 0. Now it's ready to be factored. This 4x squared could be 2x times 2x. And this negative 21 needs a negative factor, doesn't it, in order to be a negative 21. So it's either going to be a negative 7 and a positive 3, or a positive 7 and a negative 3. And in this case, the negative 7 and the positive 3 work. We set each one to equal 0, or 2x minus 7 equals 0, or 2x plus 3 equals 0. We use additive inverses to solve for x, and we get 2x equals 7. When we divide both sides of the equal sign by this coefficient 2, we get x equals 7 halves. For this one, we add a negative 3 to each side to solve for x, and we get 2x equals negative 3. We divide each side by this 2 coefficient, and we get x equals a negative 3 halves. We can substitute this into the original equation to check it. For time purposes, I'm not going to do that in this video. We'll do it in the next one. Now we have the square of a number plus the number is 156. So the square of a number is a variable squared. So I used an x squared, plus, we have a plus sign, that number again, x, equals 156. So that's our equation, x squared plus x equals 156. We're going to use a principle of zero products, and we're going to add a negative 156 to each side of the equation, and we get x squared plus x minus 156 equals 0. Now it's ready to be factored. The x squared can be broken into x times x, and again we have a negative here, so we know one of the factors is going to be a negative. It could either be a positive 13 and a negative 12, or a negative 13 and a positive 12. We can try each way, and the positive 13 and negative 12 work, and we set each one of these to equal 0. We add a negative 13 to each side, and we get x equals negative 13. We add a 12 to each side of this equation because that's a negative, so we add 12, and we get x equals 12. We plug the negative 13 into the original equation, and we do the math, and it turns out that 156 equals 156, so yes, that's true. We plug the 12 in to the original equation and get the same answer, so yes, the solution is x equals a negative 13 or a 12. Okay? Now our next video, 5.8b, we're going to do this some more. We're going to translate more words into factorable equations, and they're going to be a little bit harder word problems. Okay? I'm going to put this video into the Algebra 2 playlist. I'm going to put the Algebra 1 videos where we taught a lot of this back in Algebra 1. The links will be in this video's description, and all the previous videos that will help you for this video. Okay? All the links will be in this description. All right? I hope this was helpful. I hope you're doing okay, and I'll see you next video. Bye.